who started at Intel in the 70s at age 18.
30 years at the company. I mean, I joke, I went through puberty. I started at Intel so young.
At age 25, Gelsinger led the architecture of the 486 processor, then rose to Chief Technology Officer by 2001. He left in 2009, and after leading VMware as CEO for nearly 9 years, returned to run Intel this year.
We needed a technology leader to help reestablish the technology company, this company that essentially put the silicon in Silicon Valley.
Gelsinger's made some major moves since he took the helm, most notably the decision to double down on manufacturing. For decades, the markets have rewarded giants like Apple and Qualcomm for being fabless, but the chip shortage has made manufacturing chips a more attractive business, allowing TSMC, for example, to raise chip prices as much as 20%.
It takes time to build this infrastructure. But the good news is the world is rallying behind building additional capacity.
Intel is adding capacity by building a huge new fab at its massive campus outside Portland, Oregon.
D1X Mod 3 is about 250,000 square foot per level of the building.
We got an exclusive first look inside the expansion called D1X Mod 3.
And what exactly are you manufacturing?
We're manufacturing the latest generation of microprocessors for Intel and working to enable Intel's accelerated process for IDM 2.0.
At the company's Intel Accelerated event in July, Gelsinger laid out an aggressive IDM 2.0 roadmap for how it plans to ramp capacity and catch up with big leaps in processing technologies. By 2025, Intel says it will surpass the chip-making capabilities of both TSMC and Samsung.
We are on a march for yearly innovation, setting a pace for ourselves and the industry to not only get back, but to get ahead again.
Why should anyone trust Intel again? And so Intel will have to make a bunch of promises, both verbally and financially, in my opinion at least, to get anyone to listen.
Intel has 15 fabs all over the world: China, Israel, Ireland, and the US, in Oregon, Arizona, New Mexico, and Massachusetts. It has assembly and test sites in Vietnam, Malaysia, Costa Rica, and China and the US. It says it makes 8,000 products, outputting 2 billion units a year for some 2,000 customers. Now it's expanding that production specifically in the US and Europe. It's got a major fab expansion underway in Ireland and is reportedly in talks for projects in Italy and Germany.
Doubling down in its capacity requirement to support the growing needs of the customers around the world is absolutely a significant responsibility of what Intel's got to go drive.
And in March, Intel announced it's spending $20 billion to build 2 huge new fabs in Chandler, Arizona. It broke ground in September this year, with plans to output chips for PCs and data centers by 2024.
It's a very long time to build the concrete, the chemical delivery, the electrical systems. All of this needs to be perfect for a fab to run, for something that's creating lines and dimensions that are 10,000 times smaller than your hair.
When we toured the fab project in Oregon, semi-trucks were dropping off some of the 1,200 massive tools used to make the chips.
All of our tools tend to be in the millions of dollars, tens of millions of dollars. They weigh anywhere from 10,000 pounds to 100,000 pounds.
We also got a rare look inside the fab's bustling clean rooms, donning bunny suits that help keep dust and other particles away from the minuscule circuitry on the chips.
We're talking about a clean room that is 10,000 times cleaner than a heart surgery room.
It's about the equivalent of about 20 American football fields is the amount of space we have here, which is clean room space.
It's filled with yellow light to prevent exposing the chips to shorter wavelengths of light than the lithography machines use to print designs on the chips.
We have different chemistries and gases that we use to make our chips here at Intel, and we segregate those exhaust streams into these ducts you see here and are subsequently treated so that we're environmentally responsible in providing clean air coming out of our factories.
Making chips also takes a massive amount of water, not a plentiful resource in the Arizona desert.
We're currently out at the Ronler Acres water treatment facility, where today we've reclaimed over 2 billion gallons of water and reused back into our manufacturing systems and process.
We utilize approximately 9 million gallons a day, and we conserve about 95% of that.
The chips being made here are 10 nanometer, used in PCs and data centers. Only TSMC and Samsung can currently make 5nm chips, the most advanced node on the market. In fact, Intel relies on TSMC to make a good number of its chips.
We are one of their key customers, and that collaboration continues.